Welcome to BVS Pragathi channel. In this session, let's discuss about synchronous decade counter. Since it's a decade counter, you would need 4 bits. So if you have to store 4 bits, you need 4 flip-flops. So it's a 4 flip-flop counter. And we see that the clock pulse is applied simultaneously to all the flip-flops. Hence, it's a synchronous counter. And all the flip-flops change its state during the negative edge of the clock. Okay. Now, since it's a decade counter, it should count from 0 to 9. And after the 9th state, it should go to 0. So at the 9th state, which are the bits which are high? At the 9th state, that is when the value should be 1001, QD, the MSB is high and QA, the LSB is high. So after this, what should happen? QA should turn low, QB should become 0, QC should be 0 and QD should be 0. Okay. So for both of these to be 0, what happens? What should we do? We should take both the values of QA and QD and design the counter in such a way that QD goes low and QA goes low at the next pulse. So what we should do? Take the inputs. So take this QD as input, one of the input, and QA as one of the input to AND gate 4, whose output is applied to OR gate. Okay, and the other input to OR gate is the output of AND gate 3, whose inputs are QA, QB, QC. So flip-flop D would change its state. See, flip-flop D, this changes its state when QA was high earlier, QB was high earlier, and QC was high earlier. Okay. It changes its state at that point. Or it would change its state when QA is high and QD is high. That is what we have designed. So once QA and QD reaches high, what happens? The output of AND gate 4 goes high. Hence the output of OR gate goes high. So J and K inputs go high. Flip-flop D toggles. And in the next state, the negative edge, what happens? Flip-flop D goes low. And since flip-flop A anyways toggles every pulse, so the negative edge of the next pulse, it goes 0. QB would continue to be 0. QC would be continuing to be 0. Okay. That's how we have designed a 4-bit decade synchronous counter. So what are the advantages of synchronous counter? The advantages is it is faster. It's also called a parallel counter. Okay. And there's no propagation delay. So that's all for this session. More in the next session. Thank you. Thanks a lot and I wish you all the best.